Hello, my name is Nuria and I'm part of the Force Flow team. In this presentation I'm going to introduce you to the forecasting app in Odoo, as well as giving you some insight to different forecasting techniques. Let's start. I've divided this presentation in 4 main parts. In the first part I'm going to explain you how forecasting app could be useful for your company, as well as which are the existing forecasting techniques. In the second part I am introducing an example as well as the forecasting app. Finally, you will be able to see 2 different models, Arima and Profit. These 2 models are 2 of the models available in this forecasting app and one of the most famous ones. How could forecasting app be useful for our business? Forecasting app could be useful because it will let you predict multiple variables. For example, leads, sales, or some supplier lead times. Knowing these variables beforehand could be very valuable for your company because you will be able to set goals, anticipate market changes, or plan the budget of your business. Which tools can we use to perform this forecasting? There are several ways to do forecasting. The tools can be divided in 2 main groups, qualitative and quantitative analysis. In this case, forecasting app is based on quantitative analysis. Quantitative analysis, to perform it, is essential to have historical data. And it, at the same time, can be divided in 2 main groups, time series and causal forecasting. Our 2 models, Arima and Profit, I mentioned before, are inside the first group, time series forecasting. This group is based in the fact that time is the main regressor or explanatory variable of our variable of interest. The variable of interest could be leads, sales, supplier lead times. Before going to the example, I would like to remark a famous quote said by George Box, which was a statistician, who said that all models are wrong, but some are useful. This means that a model won't explain 100% the reality, but it can give us an approximate point of view of it. Let's start explaining the example I thought about how could we use forecasting app. Let's imagine we are an Odoo partner who wants to know the future forecast, the future leads of our business. We have monthly data of these leads that goes from 2014 until 2021. Having monthly data will allow us to see if there's any seasonality during the year. Other important events we should have into account. Odoo experience, for example, could be an important event for us to increase the leads. Oka days, or for example, the Odoo Roadshow, which takes place into our city. Other factors that could affect the leads could be, for example, the investment my company is doing in Google Ads, for example. But the goal will be to forecast these leads 1 year ahead, so 12 months. First model we're going to try to do this task will be Arima. Now I will quit the presentation and I will go to the forecasting app. This is the main page of forecasting. As you can see, I have 2 forecasts on here. I'm going to go to the first one. We can see this is an Arima forecast. Here you can see the method. But first I'm going to explain a little bit, for example, the period. Here we could introduce monthly data, daily data, weekly data. In this case, as I said before, we have monthly data. How many periods we want to forecast? In this case, we want 1 year or 12 months. Which profile I have selected? In this case, the profile contains Arima model, and which is the demand source, in this case a CSV file. It could also have been an Excel file or an Odoo model. Have check on the compute performance metrics, and I have computed the forecast. Fine. Here I can see the two plots the Odoo app is giving to me. The first plot, what does it represent? You can see two lines, the blue one and the orange one. The blue line represents our time series. So, how many leads we have had since 2014 until 2021. And the orange line represents how many leads per month has the ARIMA model predicted. As you can see, there are some differences, but they are quite similar. This is a good sign because they are not exactly equal. If they are exactly equal, this means that there exists overfitting, and this is something we want to avoid. So we could be pretty satisfied with the result because we can see that the model fits very well the already known data, but is not exactly equal. Let's go to our plot of interest, which is the forecast. Here in the blue line, we can see how many leads has this model predicted that we're going to have since May 2021 until April 2022. Here in the right, we can see a table which indicates us the exact number of leads. Here we have decimals, but and you can see that May, for example, in May we have 26 and in October we have 37. Fine. Maybe another question could be, what is this blue area around the prediction line? This blue area represents the confidence interval. In this case, we have a 95% confidence interval. What does it mean? It means that there is a 95% of probabilities that the number of leads we're going to have this month, for example October, is between 29 and 45. So there's a 90% of probability that the leads will be between these two values. It gives us a kind of probability range. Fine, here we can see some metrics, the mean square error, the mean absolute error. We can see that they are pretty small, so that's a good sign. And then we can see a model summary, where we will be able to see the value of some other parameters, which can be important for maybe data scientists or someone who's more expert in the ARIMA field. But we're going to go through the next page. We can see here another additional graph here with the original time series in blue, the rolling mean in red, and the rolling standard deviation in black. Here we have the decomposition of the time series, and in the first place we can see the original time series. Second, the trend, we can see that we have an upward trend, so we are increasing these monthly leads. Then we have the seasonal component, which indicates us that there's a very clear seasonal pattern that is repeated year through year. Finally, the errors look quite random, so that's good also. And finally, we find the autocorrelation chart. And these two plots are very important to determine parameters necessary to perform the ARIMA model, but now I'm going to explain a little better. Let's go back to the presentation, and I will explain how we build this ARIMA model. To build an ARIMA model, it is important in first place to plot the ACF and PACF, which are these two correlation plots I showed you before. Through looking to these two plots, we can decide the parameters we're going to introduce to the model. Doing this interpretation is not easy. The most part of the times it is done by an expert in ARIMA or a data scientist, someone that has interpreted some autocorrelation plots. When we have decided parameters, we introduce it to the forecasting app in Odoo, and then we can compute the forecast. As I have said, it is necessary to have a person expert in the field or who has done some interpretations to perform an ARIMA. That's why it is not so attractive as Prophet. We will see that Prophet is more user-friendly than ARIMA. Any person could change parameters in Prophet, and it has a very good interpretation of them. Let's go to the forecasting using Prophet model I have done here in Odoo. In this case, we have the same form. We can select the period. It's the same monthly, 12 periods to forecast. And in this case, I have selected a profile which contains the Prophet model as a method. File is the same, and here we obtain this plot. This plot contains all the information we have seen in ARIMA before. In the first place, we can see these black dots. These black dots represent real data. Data we have introduced, data that is past, and we already know. The blue line represents the prediction the model is doing through periods. We can observe here that since May 2021 there are no black dots because this is the future, but we have the prediction of this period that Prophet has done. Red line represents trend. As we have seen in ARIMA, we can see an increasing trend, which is good, and here we can see this vertical red dotted line. This line represents a change point, or what's the same, a change in the trend slope. If we want to analyze more the data, we could go to this period and see if any unusual event happened this time that make this trend to change. We are able to zoom into the forecast if we want to see better predictions for Prophet has made for this period, 12-month period. But we're going to go to the forecast components chart. Again, we can see a decomposition of the time series. We can see the trend, an upper trend. We can see here that there's a slightly slope change. We can see the holidays, the yearly seasonality, and the additional regressors. Additional regressors and holidays, something new. ARIMA did not have these two graphs. That's very specific of Prophet, and it's one of its main attractives. You can see that here there's a peak maybe in the end of the year. This could be Odoo experience, for example, that it makes our leads increase a lot. We will go through it when I explain the different parameters of Prophet, but here you already see that there are some events here that make the number of leads change. The regressor is the same. You can see that through time the value of the regressor increases or makes the leads decrease. We'll see which is this regressor in this case. And finally we can see also some metrics here. Depending on the horizon days there are different measures, and these metrics can be plotted, and you can see here the different plots of every metric. I go back to the presentation to summarize a little bit the different parameters that we have in Prophet, how to build a Prophet profile. We will see it in Odoo app also, but I will give you a little introduction about how many components a profile of Prophet has. First, we have to set what kind of trend do we have, if it's linear or logistic. We can establish seasonalities, weekly, daily, or yearly. Create a custom seasonality, create a holiday grid, add additional regressors, change points, and finally compute the forecast. Let's go back to the Prophet, and here, clicking in the Prophet profile, I will go to all these parameters I have just mentioned now. Fine. First place, the growth or the trend. Here we have two options, linear and logistic. In this case, we select linear. Why? Because there's no maximum number of trends we could have in a month. Uncertainty intervals. In this case, we have input a 95 confidence interval, but we can change this number and have an 80% confidence interval, for example. Seasonalities. Here we have the three possible seasonalities Prophet has: yearly, weekly, and daily. In this case, I have selected that the model itself, it will detect if there's or no this kind of seasonalities. Obviously, as we have monthly data, we could only have yearly seasonality. Then, change points. As you can see, I have the option to add or not the change points to plot. And here we have a new parameter, which is the prior scale. What does it represent, this prior scale? This parameter represents flexibility of the model. If a model is more flexible, it will fit better to our already known data. But this could cause, as I said before, overfitting. And overfitting is something we want to avoid. The bigger this number is, more flexible is the model. That I prefer to keep it very low level to be more conservative. Fine. Now I'm going to explain the specific characteristics of Prophet model and the reason why it's so user-friendly, this forecasting technique. In first place, we have the holidays. We are able to select in which country are we living in order that the model itself will be able to know which days are holidays and which not. For example, maybe if in the 25th of December we don't have any leads, that's normal because it's a holiday in Spain. So the model will take this into account. But another very interesting thing are the specific events. In this grid, I can create specific events that take place during my time series, in this case, since 2014 until 2021. For example, Odoo experience. The experience took place since 2014 until 2021. And I select a date, for example, 1st of October, and I say that this specific event will have effect in my leads from 5 days before until 5 days after. So my model will take this event into account. For introducing this event, that's why I saw that peak, if you remember, here in the model. You see that peak. So the model knows that here there's an event, and you see the effect of that event in our time series. We can see that thanks to Odoo experience, the leads increase a lot. Fine, let's go back to the explanation of the parameters. I can add multiple events. For example, here I have added also the roadshow that takes place in Barcelona. I said that this roadshow takes place every 6th of July and that its effect can last until 1 week after the event. Okay, then I have regressors. What is a regressor? When I add an additional regressor, is an additional explanatory variable. Now the time series does not only depend on time, it can also depend on other variables. In this case, Google Ads investment. Maybe the more I invest on Google Ads, the more leads I have. It could be a good hypothesis. Then change points. I can add already known change points. For example, COVID-19, that here in Spain it began all during the 13th of March. Maybe due to this change point, there could be a change into the trend of my leads. And custom seasonality. An example of custom seasonality could be, for example, that I know that the first 15 days of the month I have more leads than the last 15 days of the month. This could be introduced as a custom seasonality. And this is all the explanation of the profit model. And I finished the presentation. Thank you for your attention, and I hope you enjoy it.
I see that there are so many questions that have already been asked, so let's get right to it. First of all, let's go with Paolo Bellotti. Any chance to connect Odoo forecasts with R?
Okay, I like very much this question because R is the most used language in statistics. But the truth is that in the moment, all the models are done in Python and will be keeply maintaining this way. We are not planning to connect with R.
Okay, great. We have another question when it comes, can any what if scenario be input to project a forecast? For example, increase in price to sales forecast and or profit.
Yes, this would be an example of what I show in the last minutes of the presentation, and it would be a regressor. For example, if we have been changing our price during our historical data in our years, we could put the data of the prices we want to sell our product in the future, and this could be a regressor to our profit model. In ARIMA, we could not make that. But one of the advantages of profit is that we can add additional regressors.
Wonderful. I know that Jordi has answered a question, but Tobias Schneider has asked another question in relation to a forecast module. Does the forecast module make sense for a project-based business? Let's say something for 50 deals per year, per annum, per year.
Okay, we have to be conscious of the number of data we have. For example, profit works very well with few data, while ARIMA needs lots of historical data to make a good performance. So in this case, I would recommend to use profit model.
Excellent. Thank you so much, Nuria, for that. Another question. How to compute this model with the current outlier being the pandemic? Obviously, COVID-19 has really affected forecasting, and it's something that changed so many things. So how does that play into the particular model or module?
Okay. On one side, we are not able to predict an event like COVID-19. It's completely impossible for forecasting people to predict such an event. What we can do is now, with our historical data and the event we know that happened in March 2020, we could add, for example, in profit model, a change point in, for example, March 2020. In that point, something happens. So model knows that if data has changed from that point, it could be because of that event. So what we are saying is, let's give more information to the model to perform better in the future.
Wonderful. I have a quick question for you. Many people that migrate to Odoo have questions on how much historical data they need to actually migrate in order to have accurate forecasts. What, in your professional opinion, is a good measure to decide how much historical data should be migrated onto a new system?
Okay, this would depend what kind of data do we have. Maybe we could have monthly data, daily data, but I would recommend to have minimum 300 points of data.
Mm. Okay, wonderful. And And that could be for anything when it comes to customer sales, et cetera. Just 300 points of data as a standard rule.
No, it's an approximation, but it would depend also of the data set and the problem, the forecasting problem.
Wonderful.
But, well, more or less.
Okay, great. All right. Last question here from Eugene. What ideas do you have for implementing statistical methods in the future?
Well, we could implement more models. For example, nowadays I'm working on Holt-Winters model, which is another statistical model, and we can incorporate slowly more models and make the forecasting app more diverse and with lots of possibilities.
Wonderful. Well, thank you, Nuria, for all of your insight today. And thank you so much. If you have more questions, please feel free to contact Nuria, and she'll be more than happy to let you know about other forecasting opportunities with this forecast module. Thanks again to all of our community, and have a great evening.